Okay, so real quick today we're going to talk about sequences. A couple weeks ago, maybe in the second quarter, we talked about one type of sequence already, which was arithmetic sequences. Today we're going to intro a new sequence, and the new one we're going to do is called geometric. So remember that a sequence is just a series of numbers that have a pattern, or it could just be a list of numbers. Usually there's a pattern involved. These are two specific types of patterns. Arithmetic is it's a linear pattern, and then geometric is an exponential pattern. Okay. And there's tons of different types of sequences, but in Algebra 1 we just stick to these two, arithmetic and geometric. So real quick review of what arithmetic sequences were. The pattern of an arithmetic sequence was that each term changes by a constant amount each time. So to go from one term to the next term, you're increasing by the same constant amount each time. The easier way of thinking about that is that it's, you're adding or subtracting the same number to get to the next term. The new pattern is the geometric pattern. So the geometric pattern is, kind of similar to arithmetic, but each term changes by a constant ratio each time. So each term changes by a constant ratio each time. All right, so what's the difference between these? Constant amount versus constant ratio. Okay, like we said, the constant amount means you're adding or subtracting the same number to get to the next term. A constant ratio, I should probably spell constant right. A constant ratio means you're going to be multiplying by the same number to get to the next term. Okay, it's what makes geometric the exponential form. Okay, you just multiply by the same number each time. When you repeat multiplications, you could use exponents to do that. That's why it's exponential. Arithmetic, you're adding the same number each time. Okay, so it's pretty easy to figure out which one's which, just based on, is the pattern an addition pattern or is the pattern a multiplication pattern? Okay. Addition is arithmetic, A and A. Multiplication is geometric. All right, so now that we've described the pattern for each of these sequences, let's look at the formulas. We already did the arithmetic formula. You should remember it. It was only a couple months ago. The arithmetic formula is a sub n equals a sub 1 plus, in parentheses, n minus 1 times d at the end. Okay, that should look familiar. We did that for a couple weeks back in December. The formula for, well, let's recall what each of these pieces mean. So in the arithmetic formula, a sub n means the nth term. Okay, so some unknown value, some unknown term. So it's the nth term. Because remember, in these formulas, we don't use x and y. There's no input x, output y. We're inputting n, and we're outputting a sub n. So a sub n is our nth term. It's the output of this formula. A sub 1, you notice that the 1 is where the n was, the little subscript there. This means it's the first term. N, the next variable, n is the term number. Okay, so the nth term and n is going to be matched. So if n is 10, you're finding the 10th term. If n is 55, you're finding the 55th term. Okay, so this is the term number, or the term value, or the term, the place in its sequence. So again, the difference between n and a sub n is the place in the sequence, and a sub n is the value of that place in the sequence. And then d is the common difference. The d value, the common difference, is that constant amount. It's what makes the sequence arithmetic. It's the common difference. All right, so let's look at the formula for a geometric sequence. It's going to be very similar with a lot of the same parts. formula for a geometric sequence, this is the new one, so you're going to have to memorize this. It's a sub n equals a sub 1. Okay, so nothing changed yet. And instead of plus, because again, remember, the plus signifies that it's arithmetic, a multiplication signifies geometric. So instead of a sub 1 plus, it's a sub 1 times r, that's a new variable, raised to the n minus 1 power. Now all of these values, anything that matches the arithmetic, any variable that matches the formula in the arithmetic sequence is the same variable, okay, represents the same thing. So a sub 1 is still the nth term, or a sub n is still the nth term. A sub 1 is still the first term. So all these pieces still are important in both sequences. N is still the term number. So again, n is the place in the sequence. A sub n is the value of that place. And then r is the new one. Notice that the arithmetic sequence has a d. The geometric sequence does not. The geometric sequence has an r. So as you probably guessed, the r is your common ratio. Again, there's the only difference between the pattern in an arithmetic and a geometric. Pattern was a constant amount, a common difference for arithmetic. And the difference in geometric was it's a constant ratio, okay, or we call the common ratio. This is going to be the number that you're multiplying by to get to the next term. Okay, that's going to be your common ratio. Okay. So two very similar sequences. Arithmetic is an addition, geometric is a multiplication. The arithmetic sequence formula is a linear formula. The geometric sequence formula is an exponential formula, okay, because the variable, the input value, is in the exponent, the n value is in the exponent. But then they share, three of the four variables they share. Okay, it's still the first term for a1, it's still the nth term, a sub n, it's still n is still the term number. Okay. And then you got the common difference in arithmetic and the common ratio in geometric. So that's the basics of it. Let's look at some patterns real quick and just, see if we could find the difference without looking at a formula. Just looking at a sequence, can we see what type of sequence it is? All right, so cut ahead and I wrote down some sequences down below. We're going to determine if the following sequences are arithmetic. If it is, find D, the common difference. Geometric. If it is, we're going to find R, which is the common ratio, or neither. Okay, again, because not all sequences are one of these two. There's a bunch of different types of sequences. All right, so the first sequence I wrote down is -4, 8, -16, 32, -64. Okay, so we need to find the pattern in this. Okay, so this one's clearly not an addition problem. Okay, it's not adding to get to the next term. We need to figure out how are we going from -4 to 8, from 8 to -16, from -16 to 32, etc. Okay, how do we get to the next term? And it's obviously it's not at the same number between them. And arithmetic sequences will never alternate between positive and negatives, okay, because it's always going in the same direction. Geometric sequences and other types of sequences can, though. Okay. So this one's not arithmetic, so we ruled out arithmetic. It could be geometric or it could be neither. One way to find the common ratio, and this is similar when we were finding the common difference. Again, common difference is a little easier to figure out because you're just adding a number to get to the next one. If you want to try and figure out if there's a common ratio, you could find an R value, the common ratio, by taking any term, so any term, let's say a sub n, and dividing by its previous term. The previous term of a sub n would be a sub n minus 1. So you can take any term, so let's take 16. So 16's our term, divide it by the term before it, which would be 8. So 16 divided by 8 is -2. Okay. Take two different terms. Okay. So let's try to do -64 divided by positive 32. So -64 divided by 32 is also -2. Okay. if that pattern stays, if those numbers are the same, if they're common, then that's probably the common ratio. Now again, you can just check. All right, so we think it's -2. If we multiply -4 by -2, do we get +8? Yes. Okay. If we take +8 and multiply it by -2, we get -16. Multiply by -2, you get +32. 32 times -2 is +64. So we are multiplying by the same number to get to the next term. So this is a geometric sequence with an R value of -2, a common ratio of -2. Okay. So you could use that a sub n over a sub n minus 1 to get an R value, a possible R value, and then just check, are you multiplying by that number each time to get to the next term? Okay. All right, the second sequence, we got 2, 3.5, 5, 6.5, 8. You could do something similar. We're trying to find, again, if it's an arithmetic, if we're adding a number to get to the next term, if it's geometric, if we're multiplying a number, or if it's neither. So you could do a similar process to find R and D. Okay, so this one is a little, most of you could probably figure this out. How do you go from 2 to 3.5? Well, it's adding 1.5. Okay, how do you know? Well, you can do 3.5 minus 2. You get 1.5. How do we go from 3.5 to 5? Well, that's also adding 1.5. Okay. And that pattern is continuing, 1.5 plus 1.5. So we're adding the same number each time to get to the next one, which makes this an arithmetic sequence with a D value, a common difference of 1.5. The third one, 1, 2, 6, 24, 20. Okay, so right away I could rule out arithmetic because these are they're going up different amounts. This one's +1, this one's +4, this one's +18. Okay, so no pattern in the addition. So I look for multiplications. Well, 1 times 2 gives me 2. 2 times 3 gives me 6. Going from 6 to 24 would be times 4. 24 to 120 is times 5. So this is a multiplication pattern. However, it's not multiplying by the same number. Okay? So just because it's a multiplication pattern doesn't make it a geometric sequence. So this one's neither. It could only be geometric if you're multiplying by the same number each time. Okay? So this one does have a pattern, but it's not arithmetic and it's not geometric. So we're just going to say neither. All right, and then the very last one, 81 to 27, 27 to 9, 9 to 3. So this one's going down. Okay, it's not going down by the same amount each time, so it's not arithmetic. How do we go from 81 to 27, 27 to 9, 9 to 3, 3 to 1? Well, the pattern here is being divided by 3. It's being divided by 3. Now, our sequences are always in terms of addition for arithmetic. So if it's a decreasing sequence in arithmetic, instead of saying subtracting, we say we're adding a negative. Kind of similarly with geometric, we can't say we're dividing by 3. We can't say the ratio is dividing by 3. We need to say it in terms of a multiplication. So this is a geometric sequence, but the R value, and if you can't figure it out, how do we say instead of dividing by 3, how do we say that in terms of a multiplication? Well, you could use the same pattern we said above. If you want an R value, take a term and divide by the previous. So take 27 and do 27 divided by the previous term, which is 81. That simplifies to 1/3. So our R value, instead of saying dividing by 3, we would say we're multiplying by 1/3. All right, so that's just the basic recap of arithmetic sequences, which we talked about previously, and introducing geometric. Again, the main difference here is that an arithmetic sequence is an adding the same number to get to the next term, and geometric is multiplying by the same number to get to the next term.